Good evening. Today's quote is: in order to succeed, your desire for success should be greater than your fear of failure. In order to succeed, your desire for success should be greater than your fear of failure. Today's word is solace, a person or thing that makes you feel better or happier when you are sad or disappointed. The student took solace in music. In the last lecture, we discussed addition formulae. Sine of alpha minus beta, sine alpha cos beta minus cos alpha sine beta. Sine of alpha plus beta, sine alpha cos beta plus cos alpha sine beta. Cos of alpha minus beta, cos alpha cos beta plus sine alpha sine beta. Cos of alpha plus beta, cos alpha cos beta minus sine alpha sine beta. Tan of alpha minus beta, tan alpha minus tan beta upon 1 plus tan alpha tan beta. Tan of alpha plus beta, tan alpha plus tan beta upon 1 minus tan alpha tan beta. Okay, I think we have covered 3-4 sums from exercise 3.1 second question. Okay, so I think we have to solve fourth one. We have to prove that sine of n plus 1 into a into sine of n plus 2a plus cos of which angle n plus 1 into a into cos of which angle n plus 2 into a is cos a. Okay, now we take n plus 1, right now n plus 1 into a, we replace this angle by x, and n plus 2 into a by what? By y, and therefore LHS becomes, right on, LHS becomes sin x sin y plus cos x cos y. See, you should remember all standard formulae. Now this is expansion of what? Cos of x minus y. You may rearrange the terms first. Cos x cos y plus sin x sin y. Then in the next step you may write this. Okay. Now put the values of x and y. So this is cos of n plus 1 into a minus n plus 2 into a. So cos of na plus a minus na minus 2a, that is cos of what remains is minus a. But what is cos of minus a? It is nothing but cos a, which is nothing but right hand side. After this it is better if you again say that is sine of, and so on. Fifth one, it is again a playgroup sum. Just use formula for cos of alpha minus beta. Now, what is cos of pi by 4 minus a? Cos pi by 4 cos a plus sin pi by 4 sin a. Cos pi by 4 is 1 by root 2. Sin pi by 4 is same 1 by root 2. Open the bracket to get cos a plus sin a. Now, next one. Sum number 6, prove that cos of x minus y upon cos of x plus y is cot of x cot of y plus 1 upon cot x cot y minus 1. See, expansion is comparatively simple one than factorization, rather obtaining expression in the form of cos of x minus y. So we begin with LHS. I have not written LHS as such. I have directly begun with cos of. Now, to get cot, we should have sine in the denominator. And to get that denominator, divide both numerator and denominator by what? By sin x sin y. We cannot just divide numerator, right? Otherwise, we will not be able to write equal to sine. Now I'm writing directly cos x cos y upon sin x sin y is what? It is cot x. If you want, you can write that step. In fact, you have to write that step in exam. Plus 1 divided by cot x into cot y minus 1. That's it. See, today only I have uploaded 2 files for this topic. One is theory part and second homework. So this is theory part. Okay. Now, just listen to me, but do write this after the lecture. Prove that cos of x plus y into cos of x minus y is cos square y minus sin square x. Now, use cos of alpha plus beta, cos of alpha minus beta to get what? Cos square x, cos square y minus sin square x, sin square y. Now use common sense. We do not want sin square y. So replace sin square y by 1 minus cos square y. We do not want cos square x. So replace cos square x by what? 1 minus sin square x. Right? Just open the brackets, simplify to get cos square x minus cos square y minus sin square x, which is nothing but right hand side. That's it. Don't write, just listen to me. Next, prove that tan phi a minus tan 3a upon tan phi a plus tan 3a is sin 2a upon sin 8a. Now, what is sine? What is tan? Sine by cos. So sin phi a upon cos phi a minus sin 3 upon cos 3a. In the denominator, sin phi a upon cos phi a plus sin 3 upon cos 3a. Now multiply numerator and denominator by cos 3a into cos phi a. So I get sin phi a cos 3a minus cos phi a sin 3a upon sin phi a cos 3a plus cos phi a sin 3a. Numerator is of which type? Sin alpha cos beta minus cos alpha sin beta. This is expansion of sin of alpha minus beta. Denominator is expansion of sin of alpha plus beta. Alpha is phi a, beta is 3a. So we get sin 2a upon sin 8a, which is nothing but right hand side. See, if you know results, I don't think you will find this difficult. Now, sum number 9, prove that tan 8 theta minus tan 5 theta minus tan 3 theta equal to tan. I hope you will not say from tan 8a, if you subtract tan 5a, you get tan 3a. Mathematics made simple. That is absurd. See how these angles are related. 3 theta plus 5 theta equal to 8 theta. So we begin with this. So if two angles are equal, their tangent ratios are the same. Now why to take tangent ratio only? Because in the required equation or expression relation, we need tan, simple. So tan 8 theta is tan of 5 theta plus 3 theta, tan of alpha plus beta, tan alpha plus tan beta upon 1 minus tan alpha tan beta. Now cross multiply to get this. rearrange the terms as per requirement. We need this product on the right hand side and we have to bring these two terms to left hand side. Is that clear? Yes. Sum number 10, an important one. Prove that tan 50 degree equal to tan 40 degree plus 2 tan 10 degree. Now, how these angles are related? 10, 40, 50. 50 is 40 plus 10. So tan of 50 degree is tan of in bracket 40 plus 10. Now I will not say degree every time, but angle is in degree only. Tan of alpha plus beta, tan alpha plus tan beta upon 1 minus tan alpha tan beta. Now cross multiply. In the required answer, we only need tan 50 degree on left hand side. So bring remaining terms to RHS. Now students who can use common sense will tell me, sir, we need tan 40 degrees which is there and we need 2 tan 10 degree. Tan 10 degrees already present. This means this complete part should be tan 10 degree. Actually in this step only you will notice I have written angle 40 degree as what? Complement of 50. 90 minus 50 is 40, right? What is the advantage? Let me explain. Tan of 90 minus theta is cot theta. So this is tan 50 and this is cot 50. Tan into cot is 1. So it is tan 10. Already one tan 10 is there. So we get how many? 2 tan 10s. Right now. So I will directly write tan 50 degree, tan 40 degree plus tan 10 degree. 1 upon tan I will write as cot 50 degree. What is tan of 90 minus theta? It is cot theta. So cot 50 degree into tan 10 degree as it is. So what is tan 50 degree? It is tan 40 degree plus tan 10 degree plus tan 10 degree. So tan 50 degree is finally tan 40 degree plus 2 tan 10 degree. Hence the result. Sum number 11, prove that cos 27 degree plus sin 27 degree upon cos 27 degree minus sin 27 degree is tan 72 degree. Uh, you can begin with LHS also. I have begun with RHS. Now 72 degree, see 27 should be involved. Now 27 plus 45 is 72. So 72 degree is written as 45 plus 27. Tan of alpha plus beta, tan alpha plus tan beta upon 1 minus tan alpha tan beta. What is tan 45 degree? 1. What is tan 27 degree? Sin 27 upon cos 27. Rearrange the terms, that is multiply numerator and denominator by cos 27 degree to get cos 27 degree plus sin 27 degree upon cos 27 degree minus sin 27 degree. This is nothing but LHS, but I haven't begun with RHS equal to, that is why I'm not writing LHS. Okay. So this is sum number 11. Sum number 12 is again simple one. See, you have to read the sum at least twice. Don't attack. Don't take the decision that no, I'll begin with LHS and all that. Just observe. Observe that 35 and 10 are involved, these two angles. What is their total? 45 degree. So can we begin with this? Tan 45 degrees. Again, see what is tan 45? 1. Yes, right hand side is 1. So 45 is 35 plus 10. Now tan of alpha plus beta. What is tan 45 degree? 1. Now cross multiply and rearrange the terms. That's it. On cross multiplying, so tan 35 degree plus tan 10 degree equal to 1 minus tan 35 degree into tan 10 degree. Tan 10 degree. Okay, right. Sum number 13. Prove that cot A cot 4A plus 1 upon cot A cot 4A minus 1 is cos 3A upon cos 5A. What is cot? Cos upon sine. Now multiply numerator and denominator by sin A into sin 4A. See, A into B is B into A. That is why I have written Trigo term with greater angle first. So cos 4a cos a plus sin 4a sin a. What about denominator? Cos 4a cos a minus sin 4a sin a. Cos alpha cos beta plus sin alpha sin beta, which is cos of alpha minus beta. Alpha 4a beta a. So cos of 4a minus a, that is cos 3a. Denominator cos alpha cos beta minus sin alpha sin beta, which is cos of alpha plus beta. So cos phi. Right. Now sum number 14. So you have to divide numerator and denominator by cos 15. So cos by cos is 1. What is sin by cos of the same angle? Tan. Now next step is important. Let me explain first. See, I write this one as tan 45 degrees, right? So tan 45 degrees minus tan 15. This is of type tan alpha minus tan beta. So in that case, denominator should be 1 plus tan alpha. Can I multiply by 1? Yes, it won't change. So tan 45 degrees plus tan 15 degree. So this is tan of 45 degree minus 15 degree, which is nothing but tan 30 degree. What is tan 30 degree? 1 by root 3, which is nothing but RHS. Question number 3. This is again a simple one. Sin A is minus 5 by 13. A lies in which quadrant? A is greater than 180 but less than 270 degree. So third quadrant. Cos B is 3 by 5. B lies in fourth quadrant. And we are asked to find sin of A plus B, cos of A minus B, and tan of A plus B. Now sin A is minus 5 by 13. We have solved some of this type. From sin A, using identity, we can get cos square A, which is 144 upon 169. So what is cos A? Plus or minus 12 by 13. Now angle lies in third quadrant, angle A. Cosine ratio is negative. So we select minus 12 by 13. Okay. Now cos B is 3 by 5. So what is sin square B? 1 minus cos square B, that is 16 by 25. So sin B is plus or minus 4 by 5. Now angle lies in fourth quadrant. Sin ratio is negative. So sin B is minus 4 by 5. Now what is asked? Sin of A plus B, which is sin A cos B plus cos A sin B. All the four values are known. Substitute to get 33 upon 65. What is cos of A minus B? Cos A cos B plus sin A sin B. Substitute the values and get minus 16 upon 65. Now, what is tan A? Sin A by cos A, 5 by 12. What is tan B? Minus 4 by 3. Substitute them in tan of A plus B equal to tan A plus tan B upon 1 minus tan A tan B. So what is important? Knowledge of standard formulae, and you should be able to simplify this, finding LCM, etc. So it comes out to be minus 33 upon 56. Please do write the solution after the lecture. Now we discuss important part, that is trigonometric functions of allied angles. If the sum, SUM sum, if the sum or difference of the measures of two angles is an integral multiple of 90 degrees, that is 0 degree, 90 degree, minus 90 degree, 180 degree, minus 180 degree, etc. Or in general, n pi upon 2. What is n? N is an integer. Then these angles are called allied angles. Suppose we consider an angle theta, then angles minus theta, 90 degree plus or minus theta, 180 degree plus minus theta, 270 degree plus minus theta, 360 degree plus or minus theta. All these are allied angles of theta. Now we are interested in finding trigonometric functions of allied angles of theta in terms of theta. Okay, we begin with the first set. Cos of minus theta is nothing but cos theta. Then sin of minus theta is nothing but minus sin theta. Then tan of minus theta is nothing but minus tan theta. Now how to prove this? In fact, we have already proved this, but still I can explain the logic. We know formula for cos of alpha minus beta, right? Don't write this. What is cos of alpha minus beta? We know. Now I will say this is cos, put alpha equal to 0 and beta equal to theta. So what is cos of minus theta? Cos alpha cos beta, that is cos 0 cos theta. Cos 0 is 1. So cos theta plus sin 0 0. That's it. So we get cos theta. Similarly, we can obtain sin of minus theta using which formula? Sin of alpha minus beta. I can say put alpha equal to 0, beta equal to theta. You get this. Now take ratio of sin to cos. Sin of minus theta upon cos of minus theta. That is what? Tan of minus theta equal to minus sin upon cos. That is minus tan. Okay, so in this fashion, we are going to obtain trigonometric ratios of other allied angles like 90 minus theta, 90 plus theta up to 360 minus theta, 360 plus theta. Okay, uh, I think it is better that you write this. But before that, we will discuss without actually using cos of alpha minus beta. Can we remember trigonometric functions of all allied angles? Just a minute. Yes, I'll tell you two simple rules. The results can be remembered as follows. Listen to me carefully. If you have any difficulty, you can ask after the explanation part. Above results can be remembered as follows. For angles minus theta, pi plus theta associated with x-axis. See, I am calling these angles as angles which are associated with x-axis. For example, this is x-axis, right? So minus theta, okay? Then pi minus theta. See, this is pi 180 minus theta, pi plus theta. So this is again associated with x-axis. Then 2 pi plus theta or 2 pi minus theta. So all these angles, they are associated with x-axis. For these angles, ratio does not change. Means what? Sine ratio remains sine ratio. Okay, see, this is I can't say this is the rule, this is the observation. We are making two important observations. By them we can write trigonometric function of any allied angle. I'm explaining that. Now for angles 90 minus theta, 90 means associated with y-axis, 90 plus, then this is 270, so 270 minus or 270 plus. So these angles are associated with which axis? Y-axis. Remember, for these allied angles, ratio changes, but there is certain rule. Sine will not change to tangent. The rule is add or cut co. Means what? Sine. Sine will change to what? Sine will change to cosine. Cosine will change to what? Will you say cosine? No. Co is there. So cut co to get sine. Okay. So these are, rather this is the first simple rule. Now second rule is for SIGN sign, whether it is positive or negative. For convenience, we assume that theta is acute. Immediately you will ask me, but sir, what happens if theta is obtuse? See, the results are seen to be true for any angle. You can verify that. Okay. But what is the advantage of considering theta to be an acute one? See, if theta is acute, minus theta lies in fourth quadrant. Pi by 2, see the cursor, pi by 2 minus theta lies in first quadrant, pi by 2 plus second, pi minus theta for second, not first, pi plus theta third, 3 pi by 2 minus theta third, 2 pi minus theta fourth, 2 pi, that is 360 degree, plus theta first. Now in first quadrant, all trigo ratios are positive. In second, sine cosec are positive. In third, tan cot are positive. In fourth, cos and therefore sec are positive. So let us obtain trigo functions of allied angles. If I ask you, what is cos of 180 plus theta? Two-step solution. 180 plus, ratio does not change, so cos theta. 180 plus lies in which quadrant? Third. Now in third quadrant, cosine ratio is negative, and that is why it is minus cos theta. If I ask you, what is tan of 270 degrees minus theta. Basically 270 associated with y-axis, ratio changes, tangent changes to cotangent, add co. So cotangent, that is cot theta. Now 270 minus in which quadrant? Third quadrant. In which tangent ratio? See, we are interested in finding which ratio of this angle? Tangent ratio, which is positive in third quadrant. So plus cot theta. This is not at all difficult. You have to be attentive. What is sine of 90 plus theta? Basically 90, so sine changes to cosine. 90 plus second quadrant, we are interested in finding which ratio of this angle. Sine in second quadrant, sine ratio is positive, so plus cos. Now many argue, but sir, cosine ratio is negative. I agree, but are we supposed to find cosine ratio of this allied angle? No, sine ratio, which is positive. Simple. Cos of 90 plus theta. 90 plus ratio changes, so sine theta. Now 90 plus theta, which ratio? Cosine. 90 plus second quadrant. In second quadrant, cosine ratio is negative, so minus sine theta. Actually, you need not remember this separately, because if you know these two rules, you can obtain all this, like sine of minus theta is minus sine theta. In fact, don't remember for cosec, sec, cot, because cosec is 1 by sine, sec is 1 by cos, cot is 1 by tan. Okay. See, this table is very important. But if somebody asks you to prove this, that why sine of pi by 2 plus theta is cos theta, use sine of alpha plus beta formula. Okay. Now, if tan is asked, especially tan of pi by 2 plus theta, do not use tan of alpha plus beta formula. Obtain sine cos, take the ratio, because tan pi by 2 is not defined. Okay, let me explain about this. See, 360 degree, pi radian means 180 degree, associated with x-axis, ratios do not change, sin x, tan x, sec theta. Okay. Now, 360 plus first quadrant, all ratios are positive, so plus sin x. 360 minus fourth quadrant, tan ratio is negative, so minus tan x. 180 minus second quadrant, only sine, therefore cosec positive, so sec negative, so minus sec theta. Okay, tell me about this. Okay, instead of theta, I'll be using x. So you can type this easily. X, not theta, I'm sorry. This is x. Type your answer in chat box. Okay, so 90 plus 270 minus 270 plus. Ratios will change use as per add or cut co rule. Tan changes to cot. So this is cot x. I'm just writing the ratio. Then I will decide SIG and sine. Then cosec will change to sec. Cosine will change to sine. Now SIG and sine. 90 plus in second quadrant, tangent ratio is negative, so minus cot. 270 minus in third quadrant, cosec ratio is negative, minus sec x. 270 plus fourth quadrant, cosine ratio is positive, so it is just sine x. Okay, so that's it for today.